Welcome, everybody. This is Mr. Schultz here as we dive into inverse of functions, more specifically, inverse of linear functions. So we will be able to find the inverse of a function. So what happens to a function when you find an inverse of it? Well, why don't we do it and let's see. So we're going to rewrite the function as an equation relating y with x. What does that mean? Well, if I have like f of x is equal to 2x plus 1. This is my function f. And that means, hey, do this 2 times x plus 1, or 2 times the input, and then add 1. Well, we're going to rewrite it as an equation, y is equal to 2x plus 1. That's it. Exchange, or switch, the x and y values. So instead of y equals 2x, it's now going to be x equals 2y plus 1. Now we just have to solve for y. So get y by itself. So we get y is equal to something. Don't know yet. And replace y with the inverse of the function. So instead of y, we're going to write the inverse of f of x. And then, ta-da, we're done. And then all we have to do is graph and determine the differences and see, hey, what happened here? So we have to find the inverse of the following function. F of x is equal to 3x plus 2. So what does this mean? Well, first I'm going to rewrite it. I'm going to say, all right, I'm going to say y is equal to 3x plus 2. Cool. Second part, I'm going to switch out the x and the y. Switch them. So now I have x is equal to 3y plus 2. Now I could probably put this into Desmos and get my graph, but like it's not going to be it's not something we normally work with. So I'm going to get y by itself. So I get x minus 2 is equal to 3y. So no, we're not done yet. So we have to solve for y. So what's the opposite of times 3? Because that's 3 times y. All right, it's going to be divide by 3 on both sides. And so we get x divided by 3 minus 2 divided by 3 is equal to y. What? Well, I mean, I could rewrite this and say 1/3 x minus 2/3 is equal to y. And hey, wait a second. I want to say it's the inverse. So the inverse of f is equal to 1/3 x minus 2/3. Well, we're not done yet. We need to graph it. So I'm going to go to Desmos. I'm going to input these two. So I'm going to write down f of x. It was 3x plus 2. And the inverse of f is 1/3 x minus 2/3. Well, what I'm going to do is I'm going to plug these into a graphing calculator and then just copy and paste. Now, if you're doing this, you'd probably have to do it separately. All right, so hold up in 3, 2, 1. Okay, well, looking at these two graphs, there's nothing really that's jumping out at me that says, hey, these are related somehow. But if I put them together, we will see something. So we see all right, look at it, looks like a line, cool. So a function is where every input only has one output. Think vertical line test. So if I can draw a vertical line and it can only touch once, then it's a function. Now you can already tell I'm not really drawing straight lines, so we have to use our imaginations, okay? So here's some questions. Hey, why is this first function, this red one right here, f of x, why is it a function? And why is the inverse of f right here a function? Go ahead and write your answers right now in 3, 2, 1. Okay, so you might have written a couple different things. You might have said, hey, every input only has one output, or you could have said, hey, it passed the vertical line test. Let's go on. So before we go on, I want to discuss what if we put both together? So I'm going to pause and I'm going to put both these graphs up. So hold up. All right. So if we actually put both of these together, we actually see this cool thing where it looks like it's a reflection off of y equals x. So when x equals 1, what does that mean? Well, let's write y equals x. When x equals 1, y is 1. When x is 2, y is 2. When x is 3, y is 3. So this is a reflection. So these points reflect to the other side. They reflect to the other side. They reflect to the other side. Hey, look, there's a point where they intersect right here, which would be at negative 2, comma 2. That's quite interesting. But is it important? Are we going to need to memorize it? Probably not. But it's something cool to point out. All right, let's go on. So why don't we do a check? I want you to try to do the following. I'm going to stop at every point and I'm going to throw in the answers. And I want you to see, hey, did you get it? Yes or no? Let's go on. So examine g of x is equal to negative 1/2 x plus 1. Find the inverse. So we're going to go on in 3, 2, 1. So here's our work. We solve for our inverse. We found the inverse. And then we're going to put the inverse into and the original function into a graphing calculator. And then we're going to answer the questions. Hey, are they functions? What's the definition of function? And hey, are these functions? Yes or no? And why? So let's do that. So here's our two graphs right here. Now let's put them together and see the relation. This is always fun. Understanding that, hey, look, the points come across and they invert, or I'm sorry, they reflect over y equals x right here. And that one point reflects onto the other one. That's the inverse right here. So if we had a bunch of coordinate points, they would inverse right there to the other side right there, reflect over y equals x. So here's our last two questions. What is the definition of a function? And hey, was the function and its inverse functions or not? All right, guys, you have a wonderful day. I'll catch you later. Bye.